Hello. Yeah. So this short video will be about uh, general introduction to discrete probability. So as the title itself says, we are looking at probability for discrete events. So there are some events which are like continuous events also. So we are not looking at that. We are looking at events that are discrete. Okay, that assumes value which are of discrete in nature. So combinatorics and probability have common origins because basically they involve counting. Combinatorics involve counting and probability also involves counting. Probability is almost like 300 years old. It was actually an Italian mathematician, Cardano, who actually first talked about uh, probability, and he was a mathematician and he was a gambler also. So the probability has an origin from the gambling arena. He also wrote a book on games of chance. Okay, so that was the first book on probability, which he wrote in the 16th century, but it got published only in the 17th century, maybe after around 100 years of in the after his death only it was published. But further than that, a French mathematician, Blaise Pascal, who is well known, studied this probability theory, and the prime person who defined this probability theory in a more formal way was Laplace. Laplace is another French mathematician who is also a gambler. He defined the probability in the formal way, and he gave a quantification formula to find the probability of a specific event. Okay. So here, as I said, we will be looking at for this talk, we will be only looking at the discrete probability, and which is finitely many events which are there in the specific experiment that we are talking about. So before going into the Laplace definition of a probability, we will look at some definitions, like what do you mean by an experiment, what do you mean by a sample space, what do you mean by an event. Okay, so this I am going to take it just a minute. So I will take this one into the next page. Right. So this is the one that I am talking about. So, what do you mean by an experiment? Experiment is nothing but a procedure that yields one of a given set of possible outcomes. So it is nothing but a procedure that you are doing, like throwing a dice, or so randomly selecting a page in a book, or tossing a coin. So that is an experiment, and that will give an outcome. That is one of the possible outcomes that it can have. So that is called as an experiment. A sample space is the set of all a sample space is a set of all possible outcomes. So sample space is nothing but a set, which we will denote it as capital S, and it's nothing but the set of all possible outcomes of an experiment. So for example, if I toss a coin, S will be having H and T, and if I throw a dice, it will have values from 1, 2, 3, 4, 5, 6, like that. Okay, so that will be the sample space. So it's a set of all possible outcomes of an experiment. An event is nothing but a subset of the sample space. What you are looking at, I want to look at what is the probability of getting a head. So that is a subset of the sample space H comma T. So when I talk about I want to find the probability of throwing a dice and getting a number 6, so that is an event. Okay, so now you know what do you mean by an experiment, what do you mean by a sample space, and what do you mean by an event, right? So let us go further. So now we will go to the Laplace definition of probability. What do you mean by Laplace definition of probability? So let me go to the screen here. Let me elongate this so that it becomes visible. So what do you mean by Laplace definition of probability? It's nothing. It's very simple. If S is a finite non-empty sample space of equally likely outcomes. Okay, so this is an experiment in which every outcome is equally likely. What do you mean by equally likely? It means that the coin is not biased. The dice is not biased. Okay, so every outcome has an equal chance of occurring. So that is a basis of Laplace definition of probability. Okay, and E is an event, that is a subset of S. Okay, then Laplace defines the probability measure for that event, that is called as P of E. So this is the definition of probability. So P of E is nothing but the cardinality of the set event E, okay, and divided by the cardinality of the sample space S. So it is nothing but a ratio. How much is the number of element is there in the event divided by the number of element in S. So E is going to be a subset of S. So always the value of probability will be less than or equal to 1. And both are positive values, E and S, the cardinality of E and cardinality of S. So the value will be always greater than or equal to 0. So the probability of any event will be always between 0 and 1. Okay, and since E is a subset of S, E has to be between 0 and S. Okay, so this is a Laplace definition of probability. In the next video, we will be talking about some examples of how to find the probability of a specific event that we are looking for.